Hi, this is Cam from Infinitum. Today we're here to talk about the latest version of the Infinitum motor control software. This is the screen you would see when you first start up the software, but a couple of prerequisites. You should have downloaded the latest version of the software off the Infinitum support website. You also need to determine a physical connection between your PC or laptop and the motor, and you can set those in the upper left-hand corner. As you can see, mine is set to TCP or Ethernet. You could do a serial connection. If that's your connection of choice, you need to go ahead and set that in the upper left-hand corner. If you use Ethernet, you need to have a static IP address on your PC or laptop. The motor requires a static IP address to maintain its connection. There's a couple of things you can see from this particular view. There's a support button in the lower left tab that takes you to the Infinitum support website. There's also a button that says firmware update. This is really for the factory, but if you click this accidentally or want to see this, you can see the various options available on that. To get out of this mode, just hit the support button in the lower left-hand corner. So assuming your motor was off, go ahead and turn it on. You should, if it's visible, you should see the green LED and the yellow LED should be flashing. And we're going to hit connect in the upper left-hand corner to establish connection between the PC or laptop and the motor. Now that I've done that, you can see a lot has changed on the screen. In the upper left-hand corner, you can see the communication protocol is TCP. The green text says it's connected. It shows you the static IP address. And there's a box for continuously read registers. This is clicked, which means you're maintaining this connection to the motor. For debugging some other things that we can test, you can actually unclick this and it breaks communication with the motor to test some features that you can try. There's a start logging button, which logs all of these activities to a particular file, and you can click that button to do this. There's also a save state button, which will save your operational parameters to a state that you can actually send to the factory for debugging. In the center of the screen, you can see the slider. These set the operational speed of the motor for your particular application. There's a slider that goes left and right. You can actually hit the up and down button, or you can actually just type in the value. That's quickest. I'm going to set mine to 1,000 RPM. In the center box, you can set the direction you want the motor to turn. It's actually set to counterclockwise. You can set this to clockwise if that's better for your application. In the upper right-hand corner, you can see the faults. If there were any faults when the motor first powered on, there really shouldn't be any. But if there were, you can actually clear this by hitting the clear fault button on here. There's a lot of information on the left. Most of these are more interesting when the motor is running, so I'll go over these in just a second. But I will show you a few that are important while the motor is not running. The motor information field is a tab in the lower left. It'll show you the serial number, the operational voltage, the rated speed, and the versions of the software. The TIVA, which is the processor on the communication board, it's 2.8, and the software version on the inverter board is 3.4. Most of these aren't that useful until the motor is running, so I'll save those for later. But there's a couple things just to look at. To set application features for your particular, what you're going to do with it, your particular application, you hit the parameter setting tab in the lower left, and it brings up these user configurable fields. For example, the operating limits, you can change the minimum and maximum RPM, the acceleration ramp. If you had some skip speeds, some speeds you didn't want the motor to run at, you can set 3 skip speeds here. With the bandwidth for those speeds, it gives you 30 RPM bandwidth for each one of those skip speeds. And if you wanted to control the direction, right now it's set to both. You could set it to clockwise or counterclockwise only, if that's useful to your application. The operation type is a key operation field setting. You can see mine is set to Modbus, and this is important because the software only talks to the motor over Modbus. But if your particular application, when you turn this on and enable the motor, is analog digital, you would set that here with the various fields that you want to use in the particular digital and analog inputs. Again, I'm going to leave mine as Modbus to maintain communication with the software. If you're going to run in serial RTU mode, there's a way to change the various parameters, your slave address, the baud rate, and the parity. And if you have the optional IoT module installed, this changes the poll rate of that IoT module by changing the setting in the lower box on the screen. What to do with faults? There's a fault reset field. Right now it's set for 3 retries per fault. You could set this from a low number of 0 of stop on any fault to never stop of 99 and keep trying on here. And it also shows you the delay between fault attempts. It's 2.5 seconds on here. There's a terminal strip, an IO terminal strip in the motors, and this determines these way these are set. These are all user configurable, and you can see the type on here. For example, analog 1 could be voltage or current. And the various settings available for the analog and digital are within these terminal setting files. The failover setting. Failover is a new feature we've added with the latest versions of the GUI. And a failover is what happens when your motor loses communication with its controller. Right now, mine is disabled, so if it loses communication, the motor is going to keep running. But if you want your particular application to change, if it loses communication with the controller, this is how you would do that. You need to set this to enable, and you have to hit apply to let you actually change these features, and just follow the prompts. Once you have it enabled, there's various things you could change. For example, the timeout value. Right now, mine's set to 10 seconds. If you lose communications for up to 10 seconds, it would enable this failover operation. In mine, the way it's set now, there's a failover speed that if it detects and goes into this mode, it's going to go to 750 RPM. My operational speed is 1,000, you can see at the top. If it loses communication, it will throttle down to 750. You could have another option, you could actually stop the motor. So if you set these various values, this is what's going to happen in the failover operation. We're going to go back and set these. At the end, you need to set apply to apply all these changes to your motor. So these actually change the settings within the motor. And you can see at the top, there's a couple of options here. You could save these configurations to a file. It's a JSON file, so all these settings are saved to a file. And what this is useful for, if you want to configure a lot of motors the same, you would now load the configuration for the 2 motor. You would go to this, it would set that file that you'd saved previously, and it would download that setting into the motor. So we've actually changed and set up our motor that we want for our particular application. I'm going to hit start, and you can see right now the actual speed is 0. When I want to hit start, you'll see the motor is actually turning on. So these speeds are increasing, and it'll level off at 1,000. It takes a couple of seconds for the motor to level off at 1,000. While it's doing that, you can see there's no faults, so the motor is running fine. It's at 1,010. This will level off right at 1,000, which is what the motor operational speed is set to. Now that it's running, there's much more information that is useful to it. So I've checked the parameter monitor setting on the lower left-hand corner. You can see various settings between max current, model speed, various speeds on operational parameters. You can see some electrical information. It's running at 1.35 amps, average RMS. Performance, you can see consumed power, runtime, motor runtime, drive runtime, and torque values. You can see these, and these will actually change as the motor changes speed. You'll see these change in real time down at the bottom down here. Some operational parameters are visible. So it's running, it's clockwise, the actual speed is 1122. You'll see it level off, it matches the top. And the analog and digital input-output values are available. So those are the analog values, and you can see the digital values down here in the lower left-hand corner. There's temperature settings that are available, temperature sensors that are available. You can see the stator, inverter, heatsink, and sim board temperatures. And the analog digital configuration values. This is a way to determine you've actually set up your analog and digital controls the way you want it. So for example, this analog 1 input is speed, analog out is voltage, analog out down here is voltage. You can see there's various functions, and by setting this and by looking at this, you can see the values that you determine between the parameters. The digital readbacks are much more interesting now. You can see the bus voltage, RMS current, the stator temperature, and the various powers in watts and Newton meters. And again, if I change the speed, you'll see these numbers change in real time. Okay. There's another field that's interesting. If you hit the graphical readback button, there's a way to actually set up graphing values. So the configure graph data, you can set up the left and right axis. On mine, I've set the left axis to speed, but there's various options with voltage, current, temperature, output, and torque. You can set the left axis. Correspondingly, you can set the right axis. There's torque and the various functions again. I'm going to leave mine at torque, but if you change it, you just hit apply, start graphing, and on the right side, in real time, you'll see a graphical representation of what the motor is doing. You can see it's leveled off at about 1325. If you look at the left value, that's this yellowish greenish line. And the torque is this sort of purple line. You can see it's leveling off about somewhere between 1.5 and 2. If you want to save this data, you hit the save graph data and it exports it to an Excel file. It actually exports to a file that you can actually save and go back and look at this later. So that's a quick overview of the motor. If you have any questions or comments, just drop a line to the Infinitum support website. Thanks a lot.